Hello, for chapter 12, if a linear, or what are these called? I forget what they are. Linear regression concepts. So your concepts, the first one's R squared. And it says if the linear correlation coefficient between the explanatory variable and the response variable is R equals 0.84, the slope of the regression line is positive, negative, or 0. Now when you have R greater than 0, make those bigger. When you have R greater than 0, slope is positive as x increases, y increases. Also, closer to 1, the stronger the relationship. Also, the closer the points are to the line, the trend line. If R is less than 0, so if it's negative, slope is negative. As x increases, y decreases. So in this case, your trend line is going up, where in this case, the trend line is going down. Also, closer to negative 1, the stronger the relationship. So in this case, R is 0.84, which means there's a strong relationship, and the slope is positive. If the slope of the regression line is positive, then the correlation is positive, which is true. A researcher wishes to examine the relationship between years of schooling completed and the number of pregnancies in young women. Her research discovers a linear relationship and the least squares line. So we have y equals y equals 3 minus 4x. Linear is y equals mx plus b. The one attached to the x is the slope. The other, b, is the y-intercept. Now in this one they say where x is the number of years of schooling and y is the number of pregnancies. The slope of the line can be interpreted. Okay, so our slope is negative 4. I want to make a fraction. Over 1. Because you want to think of the slope as a fraction because it's the change in y, and y is the number of pregnancies. And x is number of years of school. Now when you're explaining the slope, you always look at the bottom one. Notice this is a 1, so each year of schooling, the number of pregnancies, because this is a negative, decreases by 4. When the amount of schooling increases by 1, the number of pregnancies tends to decrease by 4. So you're looking at this going up by 1, and then this goes, because it's a negative, down by 4. That one's another negative. I wanted to... Okay, this one, it has both. From 1981 to 2010, the number B of federally insured banks could be approximated by B of T equals this. So... negative 3.7. Find the slope. T is years. Okay, wait a minute. After 1981. And B of T, that's a lowercase t, is the number of banks. Okay. Slope. The slope is attached to the variable, so the slope is the negative 329. So, and remember, this is our x, so it's number banks divided by years after 1981. To explain it then, each year after 1981, the number of banks, again, decreases because it's negative by about 329. The number of banks decreases by 329 banks per year. So each year after 1981, we lose about 329 banks. The y-intercept is the constant that's by itself. So the y-intercept is the b, well, I don't want to use a b in this case, but from the equation y equals mx plus b. I didn't want you to get b mixed up with bank. 13739. 13739. The y-intercept is when x is 0. Well, when x is 0, that's 0 years, so that's 1981. That's telling us the starting amount. It gives you a fixed value or the starting amount. And it started in 1981. So in 1981, there were 13,739 banks. Y-intercept is another number of banks in 1981. So it's just making sure you understand what these variables stand for and the R's.